Hello there, and welcome to another video by Rust Planet. I'm Akshaya, and today I'm going to be talking about Tonic. Tonic is a Rust implementation of gRPCs. It's high performance, open source, and a general RPC framework that puts mobile and HTTP2 first. Now, before I go into the actual implementation of Tonic, I'd like to give a very small introduction to what gRPCs and protocol buffers are. gRPCs are remote procedure calls, but it's an open source remote procedural call framework developed by Google. It is defined and designed to enable efficient and reliable communication between distributed systems. gRPCs use protocol buffers or protobuf as its interface definition language and binary serialization format. gRPCs is a way for different software programs to talk to each other over a network. It helps pieces of software like microservices in a big application work together seamlessly. In simpler terms, if different programs were people having a phone call, gRPCs would be like a special language that they use to talk quickly and efficiently. Essentially, gRPCs is like a skill translator. It helps different software programs understand each other's languages and talk efficiently, making it easier to build and manage complex applications. Now, by default, gRPCs use protocol buffers. Protocol buffers or protobuf is a method of serializing structured data useful for transmitting data over the wire or storing it. It's also developed by Google for serializing structured data similar to XML or JSON, but with a focus on being more compact, efficient, and faster. Now, assuming you have prior knowledge about Rust, some information about gRPCs, and protocol buffers, we can get started. Now, the general prerequisite or the only prerequisite you need for this is to have Rust up installed. And then if you have that installed, you're pretty much done. So now first, let's make a new Rust project with cargo. So we're going to say cargo new, and we are going to be calling it Hello World because I'm showing you a very basic tutorial on how to use Tonic. Now that the binary package has been created, we can get into it. Okay, so now let's define our actual Hello World service. So we are inside of it. So now let's create a gRPC service and a method request and response using protocol buffers. So we'll keep our .proto files in this directory of our project's root, and we can actually define our actual service that we are wanting to make. So we're gonna just create our proto. And now inside of it, we are going to be creating a .proto of the name Hello World. Proto.hello world. Okay, so now we've created inside this. So if we go to our files and we go inside our Hello World Tonic, we have the proto directory inside which we have our actual proto. So now this is the file where we are now going to be defining our RPC methods. We're going to have the specify our request and response types. And in general, gRPCs lets us define 4 kinds of service methods, which all of these are being supported by Tonic. But for now, we're just going to be doing a simple RPC. So first thing is we're going to define our package name. This is essentially what Tonic looks for when we're including our Proto's client and server applications. So let's name this one as, okay, so we're just going to have Proto 3. And we're going to be calling this package as Hello World. Okay, so next we now actually have to define our service. So the service will actually contain your actual RPC calls. So we'll be using this RPC calls in our application. So the RPC contains 3 main things or 3 main parts. You have an identifier, a request type, and a response type. So for now, we're going to be making a very basic greeter service. So essentially, it will just say hello, and it'll also give you a reply back. So we're going to be defining our service, which is of name greeter. Then we're going to be having our RPC, our identifier, which is say hello. Then the actual request type, which will be hello request, which then also has a response type, returns um, hello reply. Yeah. So now we actually have defined our service. We have the greeter service when we have our identifier, which is say hello. We have our response and request types. Now we need to actually define what is going to be inside of these response and request. So which we'll have like your fields inside of it. So we're going to have message. This is how you sort of define what's inside of this. So you have hello request and our hello reply. So these are actually very basic steps to when it comes to like defining in a protocol buffer also. So it's not like we're doing anything new. If you have any sort of prior knowledge about it, it should be kind of obvious. So right now, inside our request, we're going to have the name over here, and inside our reply, we'll be having the actual message that will be given back as a response. So these are of type string. Basically, hello will be the name, so hello, whatever your name is, and then you'll have a response accordingly to this. Sorry, message here. Yes. So we have our name. Whoops, that is not. Yeah. So we have the hello request, which with the name in it. We have the hello reply, which will have the response back. So now we've kind of completed what our protofile should have instead of it. Oh, wait, I also forgot to put the A. And I also like to mention, if you know anything about protocol buffers, this one is essentially a tag or an identifier. So when you're actually sending or receiving this sort of message, it's trying to say, hey, look for this specific message which is labeled this number. So this is kind of like a basic thing that's written with protocol buffers. So this is kind of a general sort of protofile that can be written. Now let's go into the actual Rust part of it. So we can do more of our application setup. So we need to start writing it with Tonic. So we've defined our protofile. So now let's go into the cargo.toml and let us include all of the required dependencies. So you can see that as this was generated, we have all of the definitions, blah, blah, blah over here. So let's actually write down our cargo.toml dependencies. So first thing is within our dependencies, we will be mentioning about Tonic itself. So obviously we have Tonic, and then the version currently we're using, which is 1.0. Then we have Frost, 1.12, and Tokyo, which is usually used for any sort of client server applications in Rust. So we have the versions that we need to mention. So you have 0.0 features. So these are all very basic sort of libraries or dependencies which are there if you have any sort of prior knowledge about Rust. Our macros, and then we have the RT multi-thread. Yep. Yeah, so these are like the basic dependencies. Yeah, so these are all, I've just sort of put in all the required dependencies over here. So you've sort of, I've commented stuff that this is the thing required for your gRPC server, for your gRPC client. So inside of our source file, we'll be including our server.rs and our client.rs. We also have the general dependencies that I had already mentioned, and we have something called tonic.build. This was essentially included because it's a very useful way to incorporate any sort of generation that we're doing for our client and server gRPC code into the build process of our applications. So we will set up the build process right now. Yeah, so let's make the build.rs file which is required. Make sure you make it in your root directory and not inside of your source, target, proto, whatever it is. So let's call it build.rs. Inside of our build.rs, we're going to be adding the following code. So we'll be writing our function main here. We're going to have the return type of result. And then inside, we're just going to have a box. And with your std. This is kind of like a very generic way of writing the function main in this aspect. So we have this. Inside our function main, we're just going to say, I want you to call tonic build, which is essentially a macros from tonic, inside which we'll have the compile proto. So over here, the compile protos was essentially take the proto file that we have declared in other parts previously. So we have the proto. Inside proto, we have the hello world proto, which is where we actually declared or wrote down our proto file. So this should be it. And then we just, obviously it's a result. So let's just have an okay response if everything works correctly. Yep. So this is I think that should be fine. Yep, box. You have your standard, you have the error which is declared here, you have the result, and any sort of error pops up. I forgot about the propagation of errors. Yep. So this should work. This is the general build.rs file which will be required. So essentially here we are having the build.rs and then it will tell tonic build that we had declared before, if you remember, in the cargo.toml. So essentially it tells your tonic build to compile your protobuf whenever you build your Rust project. And you can kind of configure this in multiple ways, but we're not going to go too much into details about that. For now, we're just sticking to the main stuff. Yeah, so next we will be writing our server. Okay, so now we are going to be making a server.rs file inside of our source so that our build process is now written, our dependencies are all set up. So now we can actually begin writing our server and client. So before doing anything, we obviously need to include or we need to import a lot of things that are required for using any protobuf or using basically Tonic in itself. So we'll call this as server.rs inside of the file. So first thing is we are going to be using Tonic. From Tonic, we are going to be taking transport. Transport, we have our server. Oops. We have the server, then we have our request, we have the response, and we have the status. So next, next we are going to be creating this hello world. Sorry, I'm saying hello world. We're going to be getting the greeter server. We're going to be naming it as greeter server. Essentially, we'll be taking the greeter trait and our greeter server structure that we have defined. Our greeter and our greeter server. Yes. Okay. And then we're also going to be defining our message types that we'll be using here. So we have again hello world. We have hello world. We need our hello reply, which is what we had defined inside the protocol, the pro.proto file. So this is not what we said. We said hello. Oops, sorry. We said hello reply and our hello response. Sorry, hello request. Yeah, so this is the hello world. We've essentially declared, okay, so there's a message types of hello world and hello this thing. So then we've imported all the various things or items required for making our server. We've also gotten the greeted trait, which is required, and we also have the structure. So from whatever is generated from the hello world.proto file, we have our message types, which is of hello reply and hello request. Now we're going to be declaring or defining our module over here. So we're going to have it as pub mod. We're going to be having hello world, inside which we are going to be including our proto file. So we're going to call this, okay, so we're going to say tonic. We're going to include our proto, sorry, and inside of which we are going to be calling the name of the package. So we had declared before it as hello world, right? Inside this. Yep. So this will now include essentially the basics right now. So we're kind of building on this. So we've kind of set up all the required imports and whatever that's necessary. So we can now get into actually including what was written inside of the protofile. Okay, so let's have a derive inside which we'll have the debug and our default. We'll be essentially making a struct of type myData. So these will have these specific traits that these will inherit. So we'll have the debug and the default. Next, we'll be going into our tonic. Oops. Tonic name, where we'll be calling our async trait inside of it. Here we'll now be actually writing the implementation called greeter, which is going to be used for this struct myGreeter. Now we're going to have the async function, function of name say hello. Oops. There you go. Okay. Say hello. We are now actually going to define. So we have the self here. Self. Then we're going to have the request, which is of type request. Then we're going to call yes hello request, which will essentially what this does is just accepts the request of type hello request. Next, we're going to say this response with this one function. So whatever it returns, we're going to have it as result. Oops, result. Inside result, we're going to call response, which was going to be what is responding. We're going to call hello reply, which was supposed to be our response, and then also the status. Yes, inside then we also call the status. Now we're going to have the actual returning. So this essentially returns an instance of this type hello reply. So now we're going to say what exactly I wanted to print. I'm going to say, hey, I got a request. Yeah, so I'm going to say I got a request, and we're just going to say what the request actually was. Now we're going to say let my reply also be what my response should be to this. So we're going to say hello reply. We're going to say what the message is. See, I want this format. I want this to be saying hello, and I want the name of the person here. So now we're going to call the dot into request, into whatever request is being called here. We're going to say dot into inner dot name. We're going to call the dot into function. So basically, you need the dot into inner to get the fields which are required for this specific thing. Yeah, and then we're gonna just end it here. And then we're also going to have, because this is of type response, so we're just going to say everything goes well. Just have the response for this. I'm going to say send back our greeting that whatever we've made over here. Yeah. Okay, so this. Okay, I made the wrong. Yeah, this is my bad. And this is also. Yikes, okay. Silly mistake. Anything else? Yeah, I got my request. Not requester. Yeah, so this is the part of it where we write the actual part of it that takes from our proto file. So now we're going to write the actual implementation for the Tokyo runtime, which will be used over here. So make sure you include that in your cargo.toml. We've already done that, so just make sure you include it if you haven't already. So we're going to just define our Tokyo mean. Now we're going to be calling the async function again. And this is going to be the main that's going to be called. We're going to have this result, inside which we're going to have the response, dots, which we have the normal then standard, D, any sort of error. The end of any. Now we're going to be defining So now inside this, that's called the let addr. So we're going to be defining the address over here. So for example, say this is the format that we're putting. So 0051. We're going to call this parse over here. In case of any error, next we're going to have the greeter, which will be calling the my greeter default. Next is our server. We're going to be calling the builder for this, inside which we're going to be having the service. Add service. Dot add service. Here you have the greeter server, creating a new greeter. We now have the greeter. So we're going to be attaching this specific address to this server, and then we're going to call, oops, didn't mean that. And then we're going to be calling the await, which will essentially wait for any sort of requests that are coming through. So this question mark, classic Rust thing, just to propagate any sort of errors that come up. And then now we're just going to say that if everything goes well, whoops, everything goes well, just call me and okay. And also, okay, I forgot the, yeah. So essentially what this does is that you have your Tokyo main runtime that you are calling on top, and then we have the function, async function, which is so Tokyo is usually used for most asynchronous functionality that's in Rust. So you're calling your async main, you're returning back your result, inside which we are defining an address. This is sort of an IPv6 loopback address, and then we have this port with which we're binding the server to. You have the migrator, you create an instance of migrator from your implementation that we had already kind of given before. We're creating a builder function. Inside this builder, we're kind of configuring the server which is inside. So we're having the service. We're calling a greeter server. We are putting or attaching the address we have inside, and then we're calling the await function. So this is kind of a version, or this is kind of like what the server should look like in general that we have done here. So now we're going to be running, so everything has been defined sort of part by part. Now we're going to be actually running this part and see if it works. Okay, so now we have written and essentially written the Rust so that we require. Now let's actually run it and see if this works. So we're going to call cargo run. We're going to call the binaries that we had defined before in our cargo.toml file. We're going to call hello world server. Let's let it build and see if this actually works. Fingers crossed. Let's see if this works. And if it does not, let's hope it does. Okay, so it is running, but we're having error. Says transport. Oh, address already in use. Okay, so basically I had run it before using this single port. So I'm gonna have to close that port and then come back to this one. So it is running, but right now it's currently in use. So I'll just close the port and then rerun this and then it should work. So now we kind of know it's already running. So now let's actually write our client to see how this would work. Okay, so now that we have the gRPC server, it's running and that's great. But now we need to actually have the application sort of communicate. So we need to have a client side, right? So similar to how you would create it for the server, we're going to be creating our client.rs. Inside of our client.rs, we are going to be including all the necessary imports that are needed for this. So we're just going to say hello world, our creator client. Client. Then we have the we have the hello request because we're going to be asking yep, hello request. Similar to how we did it before, we're just going to have the module definition here with hello world. We're going to say please include my proto file that I had as a straight up before, right? So we have to include proto, and then we're just going to call the package name, so hello world. Yeah, so this just says it's unused, but we have to use it, yeah. Okay, so we've defined our module here. The client is actually a lot simpler than it is with the server, so we don't need to have any of the service methods. So in this, we're just going to be having the Tokyo runtime that we'll have, which will essentially make the request and then print the response to our terminal. So we're going to have the Tokyo main. Sorry. We're going to have the Tokyo main in this, and then again, we're going to be calling our async function, our main. We're going to have the result as our, and inside we're going to have the same, essentially the same exact definition that we had before. Yeah, and then our error, any sort of issue comes up, which is going to be error. And then now we're going to actually define what is our response going to be. So we have the mute. We're going to have our client, which will, a mutable client, which will be called an instance essentially of the greeter client that we called before. Inside we're going to be, whoops, okay, that is not what I meant to do. Greeter client. We're going to have the HTTP. Basically, we're just going to be calling whatever port that we are sort of defining before. So I'm going to say the same address as I did before with the 501 50051, and then we're just going to call the dot await. Yeah, and then we're going to say let the request, oops, let my request be calling Tonic. We're going to call the request right here. And then we're going to say, let's create a new hello request, inside which I'm going to call this name. I'm going to say Tonic. I'm going to call the into function again. Okay. Sorry. Let's just conclude this. Yeah. So now let's say what should response be? Let's just say we're gonna call the client. We're gonna say hello. Inside we're gonna call a request, and then again we're gonna call await. Say we're gonna print whatever response is being made over here. We're gonna say response. Okay. And then we're gonna have the actual response over here. Oh, sorry, response. Oh, I forgot to put the SQL notes. And then have the actual response over here. Yeah. And then let's just call up. Okay. If everything was well, then I said okay. Okay. Let's just debug this. Any sort of errors. And I think that's it. So this will be it. And this is our complete file. This should have everything that's required in it. We have the greeter. Yeah. Okay. Next, let's run this and see if it works. Yeah. So now we've written this, and let's just run this and see. This time when we're running it, we're going to be running it as cargo run as the hello world client. Oops. It's not hell world, it's hello world, sorry. Hello world client. Yeah, and we have it running. Great. So that's about it. If you want to run your server, we'll be running it as cargo bin hello world server. And then if you want to run it as cargo run with the client, you can just run it as client in another terminal window. And yeah, so this is it. This is what happens if you run your client and your server. So that's about it. Thanks a lot for watching, guys. I hope you like, comment, and subscribe. Thank you.